Welcome to the tutorial on the connector for OMI O-DF data visualization in Grafana. This connector has been developed by Olonix for the European 2020 project bIoTope. In the IoT field, the Open Group has developed the Open Data Format, or ODF, which is an XML-based standard object notation for IoT data. It is used for data collected from different types of sensors and devices and for addressing different use cases. Such data is stored in servers or nodes, which implement the Open Messaging Interface, or OMI, another IoT standard developed by the Open Group for message exchange. The data is accessible through both a graphical user interface and the OMI query language. In the bIoTope project, Olonix explored the possibility of adopting existing off-the-shelf technologies to develop dashboard for visualization of IoT data extracted from OMI nodes. In particular, we were looking for an open-source, easy-to-configure solution that could query OMI objects and visualize O-DF data in dashboard for professionals interested in monitoring and controlling sensorized identity in smart cities. We selected Grafana, which is an open-source, widely adopted tool that allows creating dashboards from a large variety of data sources. Grafana dashboards are used by professionals who want to monitor and analyze IoT data series. Grafana can be customized for specific purposes with little effort. In bIoTope, Olonix developed a plugin capable of correctly querying an OMI node with a set of configurable options. The plugin is composed by a main core, which is the Datasource, which translates the messages coming from the OMI node into Grafana usable data, the query controller, which is in charge of creating the query for the OMI node, the config controller allowing the user to further configure the data visualization, and the annotation query controller, which can enrich the data visualization and graphs of Grafana. Any user of Grafana can use the bIoTope plugin to select any OMI node of his choice as the new source of data and configure a query to retrieve the data to be visualized in the dashboard. The data is then shown using a customizable widget. We are now going to see how to configure the data source and the query to correctly call an OMI server. So first of all, we need to define the data source configuration. The first two fields represent the name for the data source we are creating and the type of data source, OMI server in our case. Then we have to define the URL of the server and the server access. We can furthermore configure the connection, defining if the call should add a basic out header and if it should use the with credential flag. So the query takes three parameters: the XML query, which can be generated from the GUI of the OMI node and copied as is, the object type we want to filter and collect from the query response, and the table column structure for data visualization. Here can you see an example of query configuration. We are using the Grand Lyon OMI server data source and using the OMI envelope XML query copied from the OMI GUI. We want to collect all of the O-DF objects of type Sigfox communication device and show them on a table with specific columns. The columns should define the text to show on the header of the column, the type of the data, the address, and the path within the O-DF objects where the data can be found. You can use standard JavaScript notation for the path, so everything with the dot notation is okay. But now let's see a concrete example of the OMI Grafana connector, the bottle tanks monitoring for bIoTope in Lyon. Here we can see the OMI Datasource plugin among the others available plugins of Grafana on the second row on the right. As before, we can configure the data source to point to the OMI node of Lyon, which has a direct access, so we don't have to configure the basic out, neither the with credential flag. Next, we configure the query using the same parameters described before. And here is the result. The query is executed automatically by Grafana, and the plugin parses the data. It is then shown on the data table configured in the step before. So thanks for watching this tutorial, and in order to get started with the connector you can visit the GitHub page which explains how to install and configure it.